So the beauty of solar thermal air conditioning is that when it's hottest, when your building is the hottest and you need the most air conditioning, that's also when the system is operating the most efficiently, because it uses heat, not electricity, to produce air conditioning. Now, you can store the energy in storage tanks. So you generate excess energy during the day, that goes into a storage reservoir, and at night you can take the energy out of the storage tanks.
There's no geothermal project in the world that I'm aware of that will provide the ancillary services to help support the grid. Our expansion equipment has been designed to have that capability.
Here at our Kahuku project, we have the first battery storage component of any wind farm in the United States. Basically, the battery system allows us to control the output of energy from this wind farm to the utility's transmission.
The current roadmap to Hawaii's clean energy future includes interim goals for electricity generation. By the end of 2015, 15% of the state's total electricity sales should be supplied from renewable resources. Tonight, we'll hear more about how solar, wind, and geothermal are making significant strides toward that goal. The road to energy independence includes goals for conserving energy, new technology for transportation, and ramping up production of biofuels as quickly as possible. All subjects we've covered in our series of programs during the past year. But there's still confusion and certain myths about how renewable energy sources can replace oil. Myth number one: there's a silver bullet solution, one renewable energy technology that can replace our dependence on oil for generating electricity.
I don't think we ever want to be so reliant on any one type of resource. Now, historically here we have power plants that are fired on oil. What we are trying to do is we are trying to reduce our reliance on oil so that we can increase our energy security. But at the same time, as we move forward and make choices for the future types of renewables, we also don't want to just end up relying on only one type of renewable.
Hawaii's planned portfolio of renewables is diverse and raises the question, how will we combine renewables like solar or wind that are not always available with sources such as biofuel power, geothermal, and even ocean energy that are more firm and constant?
The smart grid is looking at a future where you're able to have more active control over how electricity is being used and also being produced. As we look in the future, we're going to see more, you're already seeing PV systems on rooftops all over the island. You are seeing electric vehicles now being introduced, and people are going to be wanting to plug those vehicles in. And it's becoming a much more complicated system in how we use electricity, but then also how we produce electricity. So the smart grid concept is really to improve the communications. How do we actually allow the generating resources to talk to the consuming resources in a more active fashion?
One generating resource that will replace oil is, of course, solar. Not just the water heaters and rooftop systems we see on our homes and small businesses. One of the companies that's becoming a global leader in developing large-scale commercial solar technology is locally based Sopogy, headed up by a Hilo-born and raised University of Hawaii grad.
Sopogy's technology is pretty basic. So we use optics and mirrors. Basically, we have shiny mirrors in our collector and we concentrate sunlight. From there, we focus that onto a pipe in which we circulate a mineral fluid. Heat transfer fluid is what we call that. The fluid gets to become very, very hot. Once we run that through many collectors, and in some cases it's tens of thousands of collectors, what we end up having is solar heat. So we're basically a boiler, but we use the sun, so we're a solar boiler. Once you have that, once you have a boiler, you can do a lot of different things with that heat. First of all, to understand the benefits of solar is to understand the grid. So at night, there's very little load. I'm talking 2 o'clock in the morning, there's very little load on the grid. And then as we get up and we start going to work, energy starts to rise and it stays up very high until, say, 9 o'clock at night, and then it drops back down. So what solar has the capability to do, especially in Sopogy's case where we have storage, is we can produce the energy all throughout the daytime period as well as capturing the nighttime peak, meaning that we could generate energy from 8 a.m. to 9 p.m., which will capture the most expensive and the most required component of energy that we have in a day. What we want to do is provide supplemental energy during the periods of time where you need it the most.
Sopichi has customers and partners in Latin America and throughout Southeast Asia, as well as large-scale commercial projects here in Hawaii. And Kimura says solar's presence on the local grid can help stabilize energy costs for everyone. Sopichi plans to introduce something new for residential customers.
Every 2 years or so, we have a brand new product that does something very different in the world of solar. We have a new product now that we're looking at rolling out in the near future, which will be the solution for your home. And this product could replace the photovoltaics that you have on your roof and the hot water solar panels you have on your roof in one compact product that looks cool to have. So we're looking forward to rolling that out.
When we come back, we'll take you to the island that Madam Pele calls home to visit with Hawaii's only geothermal energy provider. Stay with us. We'll be right back.
This is our oil.
This is a miracle.
Better than oil. To be successful, there's 3 key elements as far as geothermal. You need a heat source, you need a water source, and you need permeability or fracturing of the geology so that this heated fluids can travel. We're so fortunate to have Kilauea that's been producing or erupting for over 30 years. That is our heat source. So the magma is the heat source. But we don't use the magma. We use the water, which is essentially rainwater and seawater that percolates down to depth where our wells are, which is between 4,000 and 8,000 feet. We're on the lower east rift zone of Kilauea volcano. One of the, if not the most active volcano in the world. And we have a robust resource below us.
Geothermal technology was first used to produce electricity in Italy around 1904. Today, more than 25 countries use geothermal as a renewable energy source. Since its controversial introduction on Hawaii Island in the 1980s, the technology has vastly improved, and there's a shared concern and respect for cultural values. Today, on geothermal sites, you will not only find the production wells that draw the hot water and steam from the earth, you'll also find injection wells that return the cooled fluid, which is what makes geothermal a closed-loop cycle.
The resource here is on our land. It is better than oil, we have it in our backyard. It's a gift. It's a natural resource. We have to give respects to where it comes from, from a cultural perspective, environmental perspective, and it's a gift to be used wisely.
In 2010, Puna Geothermal provided power for about 15,000 households on Hawaii Island, representing about 17% of all generation. The expanded facility will take that up to nearly 40 megawatts, providing about 20% of all electricity generated on the island.
The bigger key, I think, will be the technical side, which is providing ancillary services for the grid, for HELCO.
An ancillary service is anything that supports the transmission of electricity from its generation site to the customer.
Our equipment is going to provide ability for HELCO to have control of our generation. Not the entire amount, but the expansion amount. HELCO can actually put certain parameters in, and our equipment will react to the grid. If we one day had a statewide grid, which more than likely means connected via undersea cable, we will still require equipment to regulate and maintain frequency and voltage. So the question is, do we continue to burn oil to do that, or do we look at renewables? Geothermal, we're going to prove that it can provide those critical services. And this is not a dream, this is reality. I mean, this can make things happen.
8 megawatts of geothermal additional capacity on Hawaii is very exciting. That resource, we're learning more about it all the time, about the potential. It's a huge game changer. It's also firm power. So out of all the renewable options, it provides the greatest long-term stability to grid systems. So we certainly want to see that move forward.
The geothermal resource may also be present on Maui. If Maui is one of the first islands to be tied to a statewide grid and geothermal energy can be developed to commercial scale there, that will be a big step forward. The State Energy Office, part of DBED, is responsible for supporting activities that will get us to Hawaii's clean energy future. We asked Mark Glick about our myth number 2. How do we finance more renewable energy? There's a pot of money already set aside, and we just have to decide how to spend it. Isn't that right?
Studies were being done by the working groups of HCEI. Booz Allen was hired at some point and did this analysis on, well, what's the total investment that would be necessary to fulfill this broad agenda? And it ranged from anywhere from $15 to $20 billion. So you're talking about a huge economic transformation, a clean energy economy, essentially.
How do we finance economic transformation? Who would invest in our new clean energy economy?
Project financing is really based on demand and a good business plan for each project. But if you take a step back and you look at the overall demand, one of the things that first has to occur is that there has to be a great deal of confidence, I think, in a market. We actually see a lot of demand and a lot of interest by investors and developers. Because it is wide open, there are so many different opportunities. One of the things that hopefully we've done well and that we hope to even support further is building the confidence that this is a long-range plan, it has wide support, and ultimately I think the notion of the interconnectivity, it's one of the reasons why we believe a cable is so important. It's not about any individual project, it's about being able to provide a receptacle for all the projects to participate and to be able to use these large renewable energy opportunities and options, bring them into the fray to support the largest demand, which happens to be in Oahu.
I do think Hawaii's position makes it easier to find investors. Because our energy prices are so high, there are a lot of different solutions that make economic sense. So solar pays off much more quickly here than it would in Texas, for example. So in addition to our incentives, our electricity prices actually make a friendly environment for many different technologies. We're a small market, so the key challenge is having the stable policy and showing, look, Hawaii is going in this direction, we're committed to it, our legislators and our regulators, our policymakers are all going the same direction. I think once the policymakers set the course, the investment will come.
The State Energy Office has a website for investors, providing information on Hawaii's clean energy projects. The site will be expanded to track progress. You'll find about 40 projects listed at energy.hawaii.gov. When we come back, Hawaii's world-class wind power, where it's flourishing and where it's stalled.
The advantages of wind energy is that now that you see we're in operation, the land beneath the turbine is still available for use for agricultural purposes, raising cattle. There's also zero emissions. We have no emissions from these turbines as they operate. Kaheava Wind Power in the island of Maui was built in 2006. So it's been in operation for about 5 years. It has the first habitat conservation plan for any wind farm in the United States. Basically, under the Endangered Species Act and the Hawaii Endangered Species laws, we have committed ourselves to providing a net benefit to the native birds and mammal, the Hawaiian hoary bat, that may be impacted by the project. We have 20 turbines at Kaheava presently. We are looking to put up 14 more turbines in the next year. It'll actually be a second phase to Kaheava. The first 20 turbines that we have now are producing about 30 megawatts plated capacity, and the additional 14 turbines will add another 21 megawatts.
After Kaheava on Maui, First Wind began developing a wind farm at Kahuku on Oahu's North Shore. The community was familiar with the technology because there were turbines above Kahuku in the 1980s. The people worked with First Wind on certain expectations.
We asked them, okay, if we were able to build a project here, what are some of the benefits you'd like to see from the company? So we've identified, with their help, several priorities. Flood mitigation and soil erosion here in Kahuku, education, using this project as an educational tool, as well as maintaining agriculture here in the area. Here at our Kahuku project, we have the first battery storage component of any wind farm in the United States. Basically, the battery system allows us to control the output of energy from this wind farm to the utilities transmission. As you know, wind is variable, so it goes up and it goes down. This battery facility allows us to control and smooth out that output of energy.
Right now, the 30-megawatt Kahuku wind farm provides energy equivalent to that used by about 7,700 households. And First Wind is currently building Kawailoa Wind, a new 69-megawatt project above Haleiwa that will triple the wind energy on Oahu.
We will have 30 turbines for that project that are actually cutting edge in technology. They basically have the ability to self-regulate, if you will, so that we can control the output of that energy directly from that turbines to Hawaiian Electric's transmission.
The wind resource in this area, we're told by our meteorologists that have been gathering and surveying and analyzing the wind data that we've been collecting over the past several years, that this site right here is one of the best wind resources, not in the state, not in the US, but in the world. When it's not windy anywhere else, if you're gonna find wind in Hawaii, most of the time you're gonna find it in this channel, and it's gonna come up and over this wingtip effectively. This is the area that we're talking about, and we expect that we would be able to fit the 67 turbines, and that's if they're the 3.0 megawatt rated turbine, that we could fit these in about 5,500 acres. Again, Lanai is about, say, 80 to 90,000 acres.
Much of the 90,000 acres that make up the island of Lanai used to be the world's largest pineapple plantation. Since David Murdoch took control of Lanai as part of his purchase of Castle and Cooke in 1985, he tried to replace the pineapple plantation economy with upscale tourism and real estate development. But now, Murdoch wants Lanai to be known for producing energy, and that includes the biggest wind energy project in the state. The first goal is to produce all electricity on Lanai from renewable resources. The company's solar farm is already producing 30% of the daytime peak on the island, and another solar farm is in development.
This is a unique opportunity. When the DOE is here, the Department of Energy is here, their eyes get big and they say, what a great thing. One small grid, one large power user. What a great place to try some things and really push the envelope.
In 2008, when Hawaiian Electric issued a request for more renewable energy, Castle and Cooke proposed exporting abundant wind power from Lanai to where it's needed the most, the island of Oahu. Once again, Lanai would be exporting a homegrown product, wind energy. The 3,000 residents of Lanai would also see benefits that Castle and Cooke would be contractually obligated to deliver. Jobs during an 18 to 24-month construction window to build the wind farm, and then 20 to 30 long-term positions. 1% of all revenues generated by the wind farm would go to a community benefit fund, estimated at $1 million a year. And one of the biggest benefits residents would see and feel each and every month, a 40% reduction in Lanai's current electricity rates, some of the highest in the world. That benefit could save the people of Lanai more than $1 million a year. But not everyone agrees with that plan.
We have a 5-megawatt grid. It's very small. We have a 1.2 megawatt solar farm that's not totally productive yet because it still needs to solve the storage problem. But you could make this island a world-class model of energy self-sufficiency with a couple of more solar panels, or even with a couple of windmills that would focus on Lanai. And in doing that, you could make this a training ground for employees all over the world to work on energy self-sufficiency. It makes no sense to me to take this wind from our island and send it all to Oahu and spend $1 billion when you could do just our island on its own.
Should each island just take care of its own energy independence, or should the islands be linked to shared resources? As Big Island Mayor Billy Kenoi has asked, are we an island state or a state of islands?
It's another interesting related myth. And the myth is that Oahu has plenty of energy, plenty of renewable resources. And the answer to that is no. You can't put a wind farm downtown. You can't put it in the middle of a high-density residential area. And then, too, you know, the wind in Oahu is not that good.
With 900,000 people, not counting the military and tourists, Oahu is Hawaii's population center, as well as the headquarters for business, healthcare, education, and much more that's shared with the entire state. But geography has not blessed Oahu with renewable resources equal to its energy demand. Even after developing all the wind, solar, and other resources here, Oahu can only meet a small percentage of its renewable energy needs. But Maui County and Hawaii Island, with less than a third of Oahu's population, have renewable resources and land to develop abundant wind farms, solar farms, and geothermal.
Each island needs to be energy self-sufficient. I think that if geothermal is going to be the solution to Oahu's energy crisis, then we need to think about how the cable can help that. But for me, the answer is for Oahu to address Oahu first.
It's a myth that we think that every island can be independent. That's a myth. It's not going to work that way. We have to work this together. You know, with the same people. It's the same state. We're all citizens together. Many of us are related. What is going on? If you were looking for one banner to sail under, one icon for everybody to rally around, one thing to distinguish Hawaii from every place else in the world, to make us famous and proud, to stand up Hawaii, it would be our energy. This would bring the state together in so many ways. It would make us famous and economically richer and maybe powerful, no pun intended, in our own right. And why people would oppose that astounds me, because this is the best thing that has ever happened to Hawaii. We should take advantage of it.
Tonight you saw how the sun, wind, and Kilauea volcano are generating electricity for thousands of homes in Hawaii today. The roadmap towards Hawaii's energy independence is driven by technology, policy, and investment. But our ultimate success depends on all of us. You can go to the HEPF website for more information and to view all the programs that have aired this year. We hope to continue this series in 2012. On behalf of our partner, the Hawaii Energy Policy Forum, and all of us at Hawaii News Now, have a safe and wonderful holiday. I'm Terry Okita. Thanks for joining us. Aloha.